Dimensional analysis. So let's work some examples here. Directions say which of the following equations are dimensionally correct. So we want to check and see if we have the same units on either side of the equal sign. All right, so I've written the first problem. Now I've drawn this little line here just to split the sides. So we can look back at our table and we can find out the correct units of each quantity. Here I have velocities. These are bolded. And I have time and acceleration. All right, so I've got meters per second. Okay, so I'm checking to see if these units, if these quantities over here, if the units simplify to meters per second. If they do, then it is dimensionally correct. If they don't, it's not. All right, so I've got meters per second times, we're going to plug in second for time, plus meter. Acceleration, remember, was meter per second, but we simplified that to meters per second squared. Makes the analysis a little easier. So I'm going to simplify the right side. All right, so I've got meter per second. I've got a fraction here, so I want to make the s, the second, into a fraction. Bring down my acceleration. And here, multiply fractions, multiply straight across. I got meter per second. Actually, before I do that, I can cancel the seconds here, okay? And I've just got a meter over 1, right? Which is the same thing as a meter. And I've got my plus meter per second squared. Now, can I combine these two? No, I cannot. Meters represents a length unit, like distance or position. Meter per second squared is an acceleration. I cannot combine a length unit and an acceleration unit. Can't do it, okay? So this is not equal. So no. All right. Okay, let's look at another one. V, final velocity is equal to initial velocity plus V2 over 2. Okay. So in this case, again, guys, these are velocities. Bold it. All right, so we're going to draw a line. This is optional. All right, so I've got meter per second on the other side. Now, this has a number in it. Now, remember, guys, if anything that has a number, a factor that's being multiplied in your formula, you can ignore it, okay? If it's just a scalar number with no units, then we just ignore it. So this is like if I ignore the 2, remember, this is the same thing as a 1/2 times V1 plus V2. Okay, so I'm pretty much ignoring this. And I have a velocity unit plus another velocity unit. Meter per second plus a meter per second. Okay. So if I combine the terms here, I'm going to have a meter per second. Okay. A meter per second plus a meter per second will give me another meter per second. So this is equal. Yes. So this does check out. All right. Okay, let's look at another one. I'm going to go V2 squared equals V1 plus 2AX squared. Now you're looking at this and you're like, oh, I've got exponents, all this other type stuff. Well, makes no difference. Okay. So I'm going to draw my little line here. And we just have to remember the rules of exponents. That's all. All right. So again, velocity. Again, these are V's, guys. Guys, we normally talk about velocity. You guys probably know that. It's a little bit more. It's a vector quantity, right? So we like vector quantities. All right. So this is a meter per second, all squared. and this is a meter per second, plus, again, I'm going to ignore the 2. Again, this 2 has no significance on anything that we're talking about. So acceleration is meter per second squared, and then x is position. That is a meter squared. Okay, so I've got all of this. Looks daunting, but we're going to simplify. Let's start on the left side. A meter per second, all squared. I've got to square the top and square the bottom. Most people forget to square the bottom. Okay, this is a fraction that is all squared. So I square the meter and I square the second. Okay, so I'm trying to see if this right side looks like meter squared per second squared. All right, let's look. Meter per second. Bring that straight down. Now let's take care of this. I've still got meter per second squared for the acceleration. And now this is just a straight square, meter squared. So I've got meter squared. Okay. All right. So the left side is simplified. We can't do anything else with that. So let's look over here. I've got a fraction times a whole number. I'm going to bring this down. Can't do anything with a meter per second. That's good. Plus, let's make this look like a fraction. Meter per second squared. Meter squared over 1. Okay. Now, I cannot cross out anything here. There's nothing common on the numerator or denominator. So I just bring this down. So I have to multiply straight across. A meter times a meter squared gives me, a meter cubed over a second squared times 1 is seconds squared. Okay, so guys, this is nothing. I cannot combine a meter per second and a meter cubed per second cubed. I can't do it. All right, so this is not equal to a meter squared per second squared. So no. Let's look at number 4. X is equal to 1/2 a t squared. All right. Okay. Well, since I'm only talking about units, again, I can ignore the 1/2. So if I draw my line, this x position is in meters. Acceleration is meter per second squared and second squared. Okay. Well, if we simplify the right side, this is meter per second squared, and this is just a straight square, second squared. I've got a fraction times a whole number, so I'm going to rewrite the whole number as a fraction. So second squared over 1, and I see that second squareds cancel, and I just have a meter over 1, which is a meter, which is equal to a meter. Okay, so we do like this one. Yes. All right. Now, if I just flip this this problem, number 4, x equal 1/2 v t squared, what happens? Do you think that it's going to match up? Let's see. Well, if we do the same thing that we did before, except now we're plugging in a velocity. You may be thinking no, but let's see. This is a meter. This is a meter per second times second all squared. Okay. Again, it's a meter per second times a straight second squared. If I rewrite that, meter per second times a second squared over 1. Now, I can simplify here. Okay. Rules of exponents is I can subtract the same term. So this has an understood 1. 2 minus 1 is 1. So it's going to give me a second on top. And this is going to go away. This is going to go to 1. So I'm left with a meter times a second. Meter second. Well, that is not a meter. Okay, so no, this doesn't work out. Okay, so these are just a few examples of how to perform dimensional analyses on equations. This is important because, of course, when you do your when you're calculating or when you're deriving equations from the four-step analysis, it's important to look at your dimensions and see what you come up with, because that's going to tell you a lot about the physical quantity that you're talking about. Okay? All right.